On March 15, 2023, a paper was published in the international scientific journal Nature. Megan Newcomb, a University of Maryland Geology Department assistant professor, led a team studying meteorites that had roamed space since the solar system's formation about 4.6 billion years ago. Contrary to expectations, they found many with remarkably low water content, challenging the previous assumption that all meteorites contain water. Furthermore, these meteorites, so incredibly dry, earned the nickname the driest substances ever measured among all known materials. Before delving into more detail, let's first explain the types of meteorites. Meteorites that fall to Earth are broadly categorized into three types: stony meteorites, iron meteorites, and stony iron meteorites. Among them, what we should focus on more is stony meteorites, which make up 94% of meteorites. Stony meteorites are categorized as chondrites and achondrites. Chondrites are the most common meteorites, formed from primitive materials without significant melting or differentiation. Achondrite meteorites are rocks formed from materials like those found in chondrites but underwent partial melting and recrystallization due to some heat source, resulting in unique structures. However, the 7 meteorites recently discovered are believed to be achondrite meteorites, likely originating from at least 5 different asteroids, and they are thought to have collided with Earth billions of years ago. The research team has initiated efforts to precisely determine the origins of these 7 achondrite meteorite samples. Most of the meteorite samples were found relatively close to the inner regions of the solar system, roughly where Earth is located. The inner regions of the solar system generally have warmer and drier conditions compared to the outer regions where Jupiter is located. In contrast, some of the meteorite samples have been identified as originating from the frigid and icy outer regions of the solar system. For precise measurements, removing contaminants like soil and moisture that adhered to the meteorite's surfaces after they collided with Earth was crucial. The research team carried out various procedures to reduce such contaminants. To remove surface water, meteorite samples were dried in a low-temperature vacuum oven. Carnegie Institution's spectrometer measured water content. The results were astonishing. These results completely overturn the previously held hypothesis that water originated from all meteorites. The analysis revealed that achondrite meteorite samples had less than 1 divided by 2 millionth of the mass in water content. To exaggerate slightly, it can be said that there was almost no water. Considering that it's only 1 divided by 2 millionth of the total mass, even if the meteorite that fell to Earth were extremely heavy, this amount of water would be far from sufficient to supply the Earth with the needed water. In particular, the hypothesis that meteorite impacts on Earth-generated water had previously assumed that all meteorites contain significant amounts of water. Dr. Sune Nielsen, a geologist at the Woods Hole Oceanographic Institution and co-author of this study, commented, "We knew that many outer solar system objects had been differentiated, but we implicitly assumed that they all had to contain a significant amount of water." However, this study revealed that achondrite meteorites, a type of stony meteorite, cannot supply water to Earth, concluding that only certain meteorites, not all, contain water, and thus the hypothesis that they could have influenced Earth holds true. The researchers explained that the reason why water was hardly found in achondrite meteorites is because of the conditions during the formation of achondrite meteorites. Before arriving on Earth, in their asteroid state, they melted due to internal heat, leading to the near depletion of internal water. What's even more surprising is that achondrite meteorites formed in this manner are minimally affected by their surroundings. In other words, the process of a previously water-rich asteroid, whether it was in the dry inner solar system or the watery outer solar system, transforming into an achondrite asteroid inevitably results in a decrease in its water content. To the question of then, how could asteroids from beyond Earth supply water to our planet? The researchers explained, chondrite meteorites, which are asteroids without water, from beyond the solar system, were brought near Earth due to certain causes, and these meteorites could supply water to Earth through collisions. This research outcome has had a significant impact not only on Earth but also on the study of exoplanets, as it is expected to shed light on the origin of water on extraterrestrial planets. However, there are still many problems that need to be solved. The question of how water-rich achondrite meteorites from outside the solar system made their way to Earth remains unanswered. The question of whether achondrite meteorites, if they reached Earth for some reason, could have supplied a sufficient amount of water to Earth remains unanswered at this time. Water, the origin of all life. Where did water come from and how did it arrive here, exactly? Can we really uncover the answers to all of this?